Scalable, Asynchronous, Multithreaded, and Cloud-Ready Distributed Architecture by Rickson Chu. Welcome, Rickson. And without further ado, over to you.
All right. Thank you. And good morning, good evening, uh, good afternoon to everyone. Okay, let's start with our session. So, yes, thank you for that one. Today we'll be discussing modern ColdFusion. But before that, let me just share my screen so I can show you the presentation. There you go. All right. So, the session title will be is Modern ColdFusion Unlocking Scalable, Asynchronous, Multi-Threaded, and Cloud-Ready Distributed Architecture. Um, and While the title says a lot, the architecture behind building it is simple yet brings a significant impact to your application's overall design and infrastructure. So before that, I would just like to formally introduce myself. So my name is Rickson Chu. I'm from Semify, all the way from Manila, Philippines. So I am a software engineering manager with several years of experience in various web and application programming, managing a technical team, providing expertise in determining the strategical technical direction, project and dev management, and system architecture for initiative and sustainable projects in collaboration with several respected companies and very creative people, including those in the Fortune 500 lists. So these are some of the companies I've worked with and collaborated with. You may see a small, medium enterprise grade level app companies here. So I'm very fortunate and also great to work with these companies. So before that, I would like to share a brief history of what is my journey to Cold Fusion. So my journey to Cold Fusion is came after working with various tech stacks over the years. What started as a shift driven by project needs ended up with being a pleasant surprise. So Cold Fusion delivered not just speed and simplicity, but also robust support for object programming and seamless integration with both legacy systems and modern architecture. So listed below are the programming languages I've worked or used before transitioning to ColdFusion. Just to name such, .NET, ASP, C Sharp, Java, Python, PHP, the usual HTML, CSS, and JavaScript, jQuery, React, Vue.js, Angular, TypeScript, Next.js, and of course, for database, we have the MySQL, Postgres, all these before transitioning to ColdFusion. So, would like to know if you do a research about Cold Fusion, you'll notice a lot of discussions stating that CF or Cold Fusion is dead or isn't dying language. But the question is it? Not to start a tech stack difference, but that's the same thing that the dev community has or is describing other programming languages. However, that or those language is still able to cope up. Same with Cold Fusion. It may not be as large as other community. However, the ability of its ecosystem is able to adapt would suffice that it is a language that's able to run with modern technologies. So the presence of longtime experts in this technology is a testament to the strength and reliability of Cold Fusion. This community even proves that this language continues to evolve and adapt to modern software architecture. It didn't take long to feel productive as the language offers a refreshing blend of simplicity and flexibility. Having recently explored this tech stack myself, I've seen firsthand how well it holds up in today's development landscape. So, if you are a developer or a business looking for a tool that just works without the usual complexity, Cold Fusion is definitely worth exploring. As I myself, coming from years of working with various tech stack, I was genuinely impressed by how intuitive and capable Cold Fusion is. So, in this session, I'll be discussing how Cold Fusion easily integrates and adapts with today's modern tech stack. So before that, what am I looking for in a tech stack? So if you'll see here, for different languages, and then looking into the ColdFusion. First off, simplicity. With simplicity, you have rapid development, ability to set up, configure, build, and deploy web applications seamlessly, built-in functions, boilerplates that reduces development time, integration friendly. You can integrate different Java libraries, RESTful APIs. Then, of course, scalability, asynchronous processing, cloud deployment using AWS, Azure, or whatever service provider that may be. Then, of course, community, continued support with regular updates, security patches, annual conferences like the Adobe ColdFusion Summit, and of course, longtime developers with extensive experience who contributes to forums, blogs, and open source projects. All right. So when I'm building web applications, I usually look into, or how will I be able to categorize them into, let's say, a small or medium enterprise grade level application. So with that, when I'm looking for a programming language, I have three key requirements for instance this small scale web application. First off, OOP. OOP, object-oriented programming, modularity, code is organized into classes and objects, allowing you to break complex problems into manageable, reusable components, reusability and scalability, ability to extend logic which can be reused across components or modules. Next off, we have the MVC, model view controller. With that, we have the separation of concerns. With the model, we have the business logic, the view, which is your presentation layer, then controllers, the dispatcher between the model and the view. And then, of course, we also have the RDS or database. It could be an RDS or a NoSQL database, as long as you'll be able to save data. It can be a text file or whatnot. Then for classifying medium, large, or enterprise grade level applications, I also have three key requirements for that one. So first off, we have caching. With caching, it improves the performance by reducing the need to fetch data from the database or external APIs repeatedly. You have compatibility with File, Redis, Valkey, Memcache. Then next, we have multithreading, concurrent processing by running multiple operations in parallel without blocking the main thread. Then lastly, this one is very, very crucial for me, especially for enterprise grade level applications that requires a lot of complex processing or compute processing behind. It is, of course, job queues. So with job queues, compatibility with SNS, SQS, RabbitMQ, Kafka, a lot of messaging or message brokers there. Because with job queues, you can have the ability to do asynchronous workflow. It's also fault tolerant. And of course, scalable processing as jobs can be distributed across multiple workers to scale. So with all that, the topics that we'll be presenting here is by integrating AWS SNS and SQS into ColdFusion job queues. We enabled scalable, reliable, and decoupled processing, leveraging post execution hooks and multi-threading, typically found in more advanced architectures. There's a lot of service providers that you can utilize for job queues, but in this session, we'll be primarily focused on integrating AWS SNS and SQS. So I basically divided into two. The first part will be asynchronous job queue with post execution hooks, while the second part will be AWS SNS and SQS integration utilizing fan out architecture. So first off, job queues and post execution hooks. So just to understand what job queues are or what job queues is, um, first is it's a system managing task to be executed sequentially or concurrently, can be scheduled, prioritized, and handled asynchronously to improve application performance and responsiveness. And common use cases, email processing, data processing, CRUD operations, and background task execution. So what are the differences between using job queues versus or compared to direct API request? So just to give you a quick diagram of its differences of what it's capable of. In direct API request or without job queues, the task is immediately executed and the user will expect a response in return. When as a response, it's already the expected data or response that the user will need when they send that request. However, if the task has some complicated logic, business rules, or complex data with um, data processing behind, then the user will need to wait for a while for the API to uh, return that expected response. This is perfect for simple requests that doesn't have any complicated nor complex data processing and will be able to immediately return the response. While with the job queues, the API will immediately return a response, not the expected response, while the task will be queued and executed in the background. In this scenario, the task is not executed immediately as it needs a consumer or a trigger to execute it. This one is ideal for complicated and complex data processing that takes time to process. So we have different types of queues. First off, is we have synchronous. It's execution per task or a task at a time. Then we have asynchronous. It's a parallel execution. Tasks run at the same time. We have also delayed scheduled execution at a future time. Priority execution based on priority levels. So just to give a quick illustration of how these different job types are. So again, for synchronous, we have job is executed after the other. Asynchronous, parallel execution are all at the same time. Delayed is scheduled or queued. Then for priority, we have let's say based on order like high, medium, or low. So for asynchronous job queues with post execution hooks, basically jobs are chained through batches. So I'm going to give you some example of that one. So for instance, we have batch A. So in batch A, it's has a task, which is task A. So when task A is completed, you now can complete batch A. Now in this scenario, once batch A is already completed, the overall task inside of it, then it can execute another batch, which we will call, say, for instance, batch B. So inside of batch B, you have two tasks, task B1 and task B2. So once they're complete, overall batch B is now completed as well. And after that, you can also execute another batch, which we will call, say, batch C. So for batch C, you have task C1 and task C2. Then once these two tasks are completed, you now can complete batch C. Then lastly, you can call another batch, which is batch D. So we have task D as well. So once task D is completed, and batch D can now be completed as well. Uh, just to give you like a real use case scenario for that one. For instance, for task A, you have an API request or first API request. Then once that's done, you can call batch B, which also sends another API request to, let's say, a third-party API. Then since it's dependent, the payload is dependent from the response from your first API request, then we can use the response from the first API request as a payload to your API request 2 and 3. There are some use cases that's like that. So once that's done, we can now execute batch C. So in batch C, it makes sense to have all the request or responses from those API requests in order for you to sanitize them and then save it to your database. Then once that's done, everything is saved to the database. you can now execute batch D, which in this case it's just update of the job status. So this means that succeeding batches will only execute if their precedent batch has completed, or what we call batch dependency. So moving on, we now have AWS SNS and SQS integration. So just wanted to define what's AWS SQS. So it stands for a simple queue service. It's a fully managed queuing service enabling decoupling and asynchronous processing. So types of SQS, or rather types of it, we have the standard. It stands for at least once delivery, high throughput, and then FIFO, or first in first out, one process, order guaranteed. Advantages of SQS are reliability, security, scalable, and easy integration, because it's also reside within the AWS ecosystem. So use cases where they want to use simple queue service or SQS for job scheduling, task manager, task management, message buffering. And then moving on, we now have SNS, stands for Simple Notification Service. It's a managed service for message delivery across various endpoints or protocols. And these protocols are, or could be an SQS, an email, an SMS, an application endpoint, and whatnot. So SNS is it enables pub sub or publish subscribe message pattern. It's kind of similar to Kafka, because they both utilize this kind of pub sub pattern. So advantages, again, it's also within the AWS ecosystem. So we have high availability, scalable, push-based messaging. And then use cases, notifications, alerts, triggering serverless functions. Then solutions benefit overview. Why do you want to use it? Of course, it's a cloud-based platform. The benefit of it is scalability, and impact is enhanced growth. So again, it's within the AWS ecosystem, so you can match it through there. Then, of course, you can also do fan-out architecture. With fan-out architecture, it's benefit of it is decoupled and distributed. And of course, impact, it's scalable and fault tolerant. Okay, so now we're going to move on to the architecture and how we can build AWS and SQS. So, but before that, wanted to discuss first long polling versus Lambda triggers. So the architectural style for long polling, wherein consumers continuously checks for messages in the SQS or in the queue, while with Lambda, it's event driven, which means AWS Lambda invokes Lambda only when the message arrives. For long polling, latency usually 1 to 20 seconds, but it depends on your configuration in your polling settings. It could be every 2 seconds, every 5 seconds. And then for Lambda triggers, latency is near real time because it's an event trigger. um, it only listens and then executes once it's a message received. So resource usage for long polling, of course, waste compute cycles if the queue is empty, because it continuously poll even though there's no message there, because it always tries to check for the message. While for Lambda, it only runs when an event exists, or what we call a paper execution. Okay, so there are multiple ways how you can architect your infrastructure, or for the AWS SNS and SQS integration. The simplest is the single queue, single consumer. So in this diagram, you'll see on the left part is your long polling, while on the right side is the Lambda trigger or event-driven architecture. So on the left side, you'll be able to see that you have your publisher at the topmost, and bottom, you'll see you have the consumer, which you can also enclose that in an auto scaling group, because the consumer is the service that actually runs or executes your job. So that one could be a long process. That's why it's better to have an auto scaling group there, just in case that it will need to horizontally scale or needs more processing power to or workers to run your tasks. So you'll also see in between you have the SNS and SQS. So the SNS sends requests to the protocol, which is your SQS, then all messages goes through a single queue. This one is ideal for small scale. And then on the right hand side, you'll be able to see that the only difference here is you have the Lambda function between the SQS and the consumer, wherein the Lambda function listens to the messages in your queue, then it sends an API request going to your consumer to trigger that consumer and execute that job. Now, going to the fan out architecture, we can now do multiple queue, single consumer. So in this diagram, again, left side, you can see that we have the long polling. Then on the right hand side, we can see the event driven. So dedicated queues per job with a generic or common queue for non-prior jobs. Use of dedicated queue is for high traffic or on-demand tasks. So question is, why not just use priority-based queue then? This means that normal queues will just be pushed at the bottom. So having a dedicated queue makes on-demand and non-prior queues run in parallel. Then if you really want to go crazy about it, we can also have multiple queue, dedicated consumer per queue. So to illustrate that one, you see that on your SQS, each of your queue has their own consumer. So use case is for really high traffic and on-demand tasks. Just to note that this requires additional deployment process because you're now deploying to multiple services in this manner. Then same goes for the Lambda on the right-hand side. Or event-driven, you have each of your queues have their own Lambda function that basically sends the message to your consumer. So if you'll notice, we are utilizing SNS in that way, but technically, we can also omit rather the use of SNS and have it through SQS directly. So why do we still need to utilize SNS if we can do it this way? If you can see, you only have an SQS, then directly passed on to the Lambda function or directly into the consumer. Well, first off, is because of flexibility, and with flexibility, you have the ability to push to different protocols such as SQS, emails, or endpoints directly through AWS without or with less need for a code change. So imagine um, initially your business rule is to send to an email to an SQS, and then after some time, there's a need to change from SQS to an email. So what do? We go into our code base, we do an update, we change the logic and all of that, we deploy, and we call it a day. But you see that there's risk for or human intervention in between where you change the code. You need to rewrite the code just for a protocol change, which is from SQS to email. But with utilizing SNS, you can go to your AWS console, switch from SNS to email. But of course, if you've written your code into such a way that you can switch from different protocols, that will be less code to maintain rather than rewriting or creating a new function or method just to replace the SQS logic to an email. But with AWS, just click on go to your SNS topic, change the protocol from SQS to an email or an endpoint, and do some little code change, and you're good to go. And of course, scalability. We are able to scale and distribute messages to various or multiple protocols. So how do we create an SNS in AWS? So of course, you just log into your AWS console, and then on the search bar, you'll be able to search for Amazon SNS. So you'll be redirected to this page. Then you'll see on the left side of the side panel, you'll see topics, and then you just click on create topic. After which you'll be redirected to this page for the details. We'll just go for a standard because for FIFO it's more of a priority based. So in the session we'll just cover standard type, and then just apply required fields such as the name and display name. And this one, access policy, usually it's just the basic, but I would recommend to go advanced. This is in JSON format, and the reason why is because we can assign an IAM role for your SNS, and then for that IAM role, you need to specify the policies. So in that way, it's more secured. But just for testing purposes and this demo, you can just select basic, then everything leave as default. Then next off, we have create SQS. For the SQS or queues, again, same thing. Go to your AWS console on the search bar, just search for SQS or queues, and you'll be redirected to this page. Then just click on the create queue button. Then once that's done, you'll be redirected to this page again. Same thing. Go select standard FIFO, more of an order base. So we'll just go with the standard. And then for the name, for the session, we just put a demo queue. Now for the configuration, usually just leave it as default, but you can put your values here, whichever you're comfortable with, or depends on your business rules. For encryption, we just leave it as default for just for this demo purpose, and everything is basically like enabled in this way. Then for access policy, again, for demo purposes, we just leave as basic, but would recommend again to go advanced and assign a IAM role with its corresponding policy for security purposes. Then this one, you have redrivable policy, which is set to disabled, and dead letter Q or DLQs, which is set to disable as well. We won't be discussing DLQs in this session, but basically this is where field queues will be dumped. We'll be creating our own retry field jobs in the session for simplicity. So for DLQ, when you create your queue, it will just basically create another queue with the same name but with a suffix of DLQ. So if you have your not demo, your queue name as demo queue, then it will create a demo queue underscore DLQ, and all of the field jobs will be dumped there. So now we've created our SNS and SQS. Now we need to subscribe our SQS to our SNS via SNS subscriptions. So there are multiple ways to create this and subscribe to an SNS topic. So first off, you can just go to your SQS. In this way, in this page, you'll be able to see that we have the SNS subscription tab, and just click on the subscribe to Amazon SNS topic button. Now, once you click that, you'll be able to see a choose your topic field. So in this session, we have inputted demo topic. So we just click on that one. Now for the second option, we go to our Amazon SNS, then click on subscriptions, then click on the subscription button. Then we will be redirected to this page. On the topic ERN, we select our demo topic. Then the protocol, we select Amazon SQS. Then the endpoint will be our demo queue. And that will be it. And then click on the create subscription button. Then once that's done, when you go back to your queue and go to the SNS subscription tab, you'll be able to see that your topic is now attached to your queue in this uh, tab. Now, we already created our SQS, our SNS, and subscribe our SQS to that topic. Now we'll be creating a Lambda trigger for event-driven approach. So in order to do that, we go to our AWS console, and then we select or we search for Lambda. And in this page, you'll be able to see that there's a create function button. We just click on that one, and we will be redirected to this page. So for the create function, I just select author from scratch, and then the function name, whatever function name you want it to be, then the runtime, Node.js, architecture, x86 64. Then I just click on the create function button. Then once that's done, you'll be redirected to this page. So basically, we have the Lambda code. It will be too long for this session to put a copy of this snippet, so we can discuss that offline. But just to give you a gist of what this does is it listens to your SQS queue, and then it basically sends a trigger to your consumer via REST API request. So best practice, if you have any dynamic values such as API keys or your API path, it's best to place it on the environment variables. So you'll be able to see that on the environment variable section, just below the test button. So once that's done, don't forget to click on deploy, because if you didn't click on deploy, even though it's saved, your changes won't be published or won't take effect. So optional, you can click on test just to test your API endpoint or your Lambda function rather. All right. So once it's done, you'll be able to see or add your triggers in this page. So just go to your Lambda function, then again, click on the configuration tab, then click on triggers. So you'll see that we already added 3 triggers here, the 3 SQS, but to do that, just click on the add trigger button. Then you'll be redirected to this page. So for the triggers, just select SQS, then select your queue, and don't forget to check the activate trigger checkbox, because even though you've added your trigger but you didn't activate this one, they will not be enabled. So it's by default it is unchecked. So if you want to activate it immediately, you just need to check on this activate trigger checkbox. Then if you want to disable it, you just uncheck it to disable it or to deactivate. Then to verify your Lambda process, on the overview of your Lambda function, you'll be able to see that you have your Lambda function at the top, and on the bottom side, you'll be able to see that we have our SQS. And in this function, we have already assigned 3 SQS in this way. So again, to verify if your Lambda is attached to your queue, go back to your SQS, which in this case is demo queue, and then you'll be able to see Lambda triggers tab. then you'll be able to see that your Lambda function is now listed here. And you can also create Lambda functions here directly. As you can see, there's a configure Lambda function trigger button. Okay, so fan out architecture. So this section we will demonstrate how we will set up and configure a fan out architecture in our AWS and SQS. So when do we want to use Lambda architecture? If we have one event, multiple tasks, or if you have a distributed system, or if you have a per tier or per tenant queues, such as let's say a SaaS kind of tiering. So if you have a basic or pro, wherein the pro has a higher consumer specs or higher load capacity. So, but before that, wanted to present this graph wherein we implemented fan out architecture and how it was able to improve our response time. So, when we did our test case, we basically tested in one of our services, which wherein it's basically like an analyzer or a scraper. It scrapes per website, it sends API calls to various endpoints, and then it saves, sanitizes, do some background computation for the scoring, for the grades and the levels, and then it saves into the database. And then after that one, it can also generate PDF. So there's a lot of things happening in that service. So for a test case before implementing the fan out architecture, on the blue bar graph, you'll be able to see that we have 170 seconds before implementation. Then after implementing the fan out architecture in our queuing service, we're now down to 124 seconds, which is a 46-second improvement or 27.06%. Then for our second test case, before implementing fan out, we have 145 seconds response time. Then after which we're down to 116 seconds, a improvement of 29 seconds or 20%. Then our third test case, before fan out, we have 144 seconds. Then after, we have 113 seconds, or an improvement of 31 seconds, or 21.53%. So in totality, we improve our application performance by 20 to 30%. So that's very huge for our use case. So again, this is how fan out architecture looks like. You have multiple queues. So basically, distribute message to its dedicated protocol. Again, this is for single responsibility, which is easier to debug. Messages can be executed in parallel. Fault tolerance, other queues are not affected and can still continue to execute. We have this scalability and flexibility as well. So for the event triggers, have Lambda listening to your queues, then sending that to your consumer. So in order to do that one, you need to subscribe or enable a subscription filter policy. So to do that, go back to your SNS, then click on your subscription, or you can also go to your queue and click on the SNS subscription, and then select that and click on edit. So once that's done, you'll be redirected to this page, and you'll see that on the bottom part, there's a subscription filter policy tab. Just click on edit. And then you'll see that there is a subscription filter policy checkbox. Ensure that that's enabled and select message attributes. So in the message attributes, it's on a JSON format. So what we did in our case is we put, let's say, job type audit. So a while ago, it presented like we have like three queues. So basically, those queues have their own subscription filter policy. So for the first queue, let's say we have the audit. The second, we have the scraper, and the third, we have the e-bill. So if we pass this message attribute to our message, whatever SNS will read that, and whatever message attribute it found, it will pass it on to or send that to that specific queue that receives this kind of job type or this kind of message attribute. Going to the code, we have some prerequisites. So for the package requirements, installation process and code, we just downloaded some Java SDKs. So you have the core, the SNS, and the SQS. You can do this in your administrator panel. Just download these packages. But in our case, we manually got this from a vendor repository just because we want to get a specific version, or if you want to um, just drop files here inside the live Java library folder. Then for the code, just a quick snapshot of this one, just to explain everything. Um, so we just instantiate the library or the object, and then we supply the access key and the secret key. Then you'll be able to see that on the message policy, uh, we'll able to attach the message attribute into that message, and then it will send it to our or publish it to our SNS client. Then for our consumer, same thing. We just instantiate the object and then supply the credentials like the access key and secret key. Then you'll notice that um, it is wrapped in a run async. This is for running asynchronously, and then it continuously pull for messages. Since we're getting messages in the queue, now we're just looping through each of this message. And then you'll see that we have our retry policy here. We have the process attempts. Since we didn't use the DLQ, and then we need to update the job to complete if it's done, or if it failed, it already maxed out the attempts, then we put it to failed. And after which we have the process batch finish, which means that uh, when all of the tasks are done, then we can update its batch to completed and ready finish that actual batch process. Then for the Lambda, it's quite similar but lesser in code. Same thing. We wrap it around the run async for synchronous processing. And then you're able to see that we didn't anymore instantiate any object here because we're accepting it as a REST API call from the event from our Lambda function. So that way we just process the payload, and then same steps. We process the attempts and check if it's completed, and fail if it's not, and then update the batch status. Then if you want to go crazy about it, you can wrap it in a try catch just for try catch exception, and do some logging and whatnot. So for the scheduler.cfc, this only applies to long polling, since we're listening to or continuously sending looking or listening to the queue. We put a task or scheduled task in our scheduler.cfc, which can run, let's say, for every 2 seconds or 5 seconds. So it depends on your business rules. But in our case, we just put it every 2 seconds, so it won't throttle that much. Okay, so this one is if we want to send or publish the message to the queue. So first off, we just instantiate our job batch manager component or class, and then we use it. We call the publish fan out, which is basically we'll send or just publish the message to our queue. So the message will be, let's say, batch ID 123450890. So in order for us to check if we have actually received the message from the queue, we go to our queue, which in this case is demo queue, and you'll be able to see that there's a message available, which is this one. And then we just click on our queue to enter it. Then on the top right, you'll be able to see a send and receive messages. Just click on that one. And then you'll be able to see that there's one message available. Just click on poll for messages. Okay, so once that's done, you'll able to see that the message is already listed here. Just click on its ID. And then once you click on that one, you'll see that the body, it's what we've sent. And then the attribute, you see that we have the job type wherein its values audit. So that means that this queue was able to receive the message because it has an attribute of job type audit. So if you didn't specify the job type and um, your queue doesn't have or have this rule to accept only with this kind of job type, then it will not be processed. So just be wary of passing attributes or uh, to your message, because if you fail to do so, then it will just it will just be lost. So as best practice, always have a queue that doesn't have this kind of ruling. So if you forgot, if you don't have any rule for message attribute, automatically it will be dumped into that queue without that kind of attribute ruling. All right. So in summary, we were able to discuss async job queues with post execution hooks, dependency through batches, SNS and SQS scalable and flexible queuing system, and at the same time for fan out architecture, which is a fault tolerant and distributed architecture. So again, when do we want to use fan out? If we have one event, multiple task, distributed system, or per tier tenant queues. So we also have SaaS tier kind of application wherein the basic versus pro, wherein the pro has a higher consumer specs and or high load capacity. So when do we not want to use fan out architecture? If you have strict ordering across all consumers, or if we just have simple queues. So just words of wisdom. So it's not about how many features you build. It is how confidently you architect your architecture that should build more. So yeah, that's it for the presentation. Again, my name is Rickson Chu from Semify, all the way from Manila, Philippines. So if you want to get in touch with me, you may scan this QR code, and here's also my email and website. All right. All right. So already almost 50 minutes. Any questions?
Thank you, Rickson. And I think there are a few questions in the Q&A pod. I think there is one question.
Okay, what kind of error exceptions available SNS SQS? Well, there are a lot of errors that you'll be able to encounter. Um, First off, if you were of like policies, and if it's not able to reach your if you're using Lambda or event-driven approach, if it's not able to send requests to your endpoint, so that's when you need to. There's also a in your Lambda function page. There's a like a cloud trail wherein you'll be able to see messages or what's happening in the background. It's like a log, basically. So if you want to keep watch of that one, you can go to your Lambda function, click on the CloudWatch or Cloud Trail, and directly from there, you're able to see what's happening behind the background. Or if better yet, you can also go to your CloudWatch or Cloud Trail, then put a filter for on that part on your Lambda function, and you'll able to see your logs. Any more question?
There is one in the chat. How
Oh,
compatible CF is with Azure Cloud by Padma.
okay, with Azure Cloud. Okay, we'll probably focus on AWS in this session. So we haven't really looked at into the Azure, but that will be also a great thing to look at.
Also, Rickson, you have a $50 gift card that you could give away. So, is there any
Oh,
questions
okay.
that you would want to ask and
Um,
select?
yeah, I think we can just go randomly, just like a while
Random?
ago. Yeah. Yeah, I totally forgot about that one, but yeah, we can go random for the gift card.
Uh, would you want to select anyone or a raffle?
Yeah, we can like do a raffle instead. Yeah.
Okay, done. Again, thank you for the amazing session and for joining us today. Thank you so much.
All right. Okay, if that's it, thank you everyone, and have a great day.